All right, today we're going to talk about boxes and cylinders. Really what we're going to be talking about are two concepts that are surface area and volume. And it's boxes and cylinders that we're going to use to discuss surface area and volume. First, we'll start out with volume. In the past, so far, throughout chapter 1, we have talked about a handful of different ways to measure an item. We've talked about perimeter, which is the straight line distance around a figure. We can think of that like a fence. How far would you go if you walked around the figure? And we're just talking about one dimension. It's a straight line distance. So the units there are inches, centimeters, feet, yards, miles, whatever they might be. That's perimeter. And then after we did perimeter, we talked about area. Area, instead of being the fence, area was how much space something covers. We thought of area as being like a carpet. And now we have two dimensions. Instead of just having a length, we have a length and a width. So we have two dimensions. So our units are going to be in square inches, square centimeters, square feet, could be square miles, whatever it might be. It's how much space something covers. That's area. And now the new thing we'll look at today is volume. With volume, now we're going to not talk about two dimensions anymore. We're going to talk about three dimensions. So what I want you to think of for volume is a box where we have length, we have width, and we have height. Now we have three dimensions: length, width, and height. And when we're talking about the volume, it's how much stuff would fit inside there. Like when you go to buy a refrigerator, they'll talk about the volume of the refrigerator. Often it's in cubic feet because we have three dimensions: length, width, and height. And so that's why we have cubic inches, cubic feet, cubic centimeters. When you go to buy a refrigerator, it's how much stuff you can fit inside. And that's what volume means. Let's talk about the volume of a box. Find the volume of a box with length 9 inches, a width of 4 inches, and a height of 2 inches. Now, we could do this without drawing a picture, but gosh, all through chapter 1, I think being able to draw a picture is sort of a valuable thing. So if we draw a picture of this box, and it doesn't have to be perfect, it's just a sketch. And this box has a length of 9 inches, a width of 4 inches, and a height of 2 inches. So there's our box. And we want the volume of this. Well, what would the area of just this rectangle down here on the bottom, what would the area of that be? And you could either give me the formula or the number or how you got it. What would the area of the rectangle that's on the bottom be? Okay, 18. How'd you get 18? Because remember, we're talking about the bottom of this. So it has length and width. A couple of 36s. And I'm thinking those 36s came from 9 times 4. And the reason those came from 9 times 4 is because if we want the area of a rectangle, we find that by doing length times width. And here, that area at the very bottom of this would be 9 times 4, which would sure enough be 36. Perfect. Got it, Dewey. Not a problem. Your 9 times 2 is a part of this. It's just not the one at the very bottom. So, yeah. All right. When we go to find the volume then, the volume is not just the carpet that would be on the bottom, it's how much stuff would fit inside. So if we can imagine that rectangle that's on the bottom, and then we stack it up and we stack it up and we stack it up and we stack it up, we're basically saying how many of those rectangles would fit in here. If we want the volume of a box, it's just going to be length times width multiplied by the height. Essentially, how many of those rectangles will there be inside this box? So the volume of a box is just length times width times height. So the volume of this particular box would just be 9 times 4 times 2, which would be 36 times 2, that's 72. This would be cubic inches because we're talking about volume, so we're talking about cubic inches. But on a quiz or exam, you'd just put the 72. So that's the formula for the volume of a box. It's just length times width times height. Essentially, what we're doing there is we're finding the area of the rectangle on the bottom and then stacking them up on top of each other to see how many would fit inside. Any questions on that before we introduce the idea of surface area? Great. All right, surface area. So now I have this box over here, and what I want to know is the surface area. What that is if you recycle a box, you break it down and you lay it flat, and it has all these components. It has front and back, it has left and right, it has top and bottom. So if we were to lay this box out flat, we want to know how much area that would cover. It's the surface area of the box. It's the area of all the faces of the box. All the faces of the box would have some kind of an area, and we want to find that all together. And so what we're going to do here is we're going to find the sum, which means we're going to add together. We're going to add together the area of each individual face to wind up with the area of the entire box. Some people are really good at visualization. I am typically not one of those people. But when we look at this box here, this box is going to have a front and a back. It's going to have a left and a right. It's going to have a top and a bottom. Those are the 6 sides we need to add together to get the surface area. So let's start out looking at the top of this box. So as I look at the top, let's see, this is the length of the box, and this is the width of the box. So if I'm looking at the very top of the box, that's length times width. So if I want the area of the top, that's going to be length multiplied by width. You let me know if anything doesn't make sense, if you see anything that you're not sure of. It's just length times width would give me the area of the top. So that's this right here. One thing that's true about this box is, and let me know if this isn't obvious to you, that the top and the bottom are going to have the same area. So the top is length times width, and the bottom is also going to be length times width. So essentially what I'm going to say then is I could do length times width plus length times width, but I could streamline that a little bit. I have length times width 2 times. So what I could do then, as I go to build this formula, is I could do 2 times length times width. And that's the area of the top and the area of the bottom. Let me know if anything isn't clear or doesn't make sense. Now let's look at the front of this. Okay, well the front has the length and the height. So the front is the length multiplied by the height. That's how I get the area of the front of this box. Length times height. So the front is length times height. What else will also be length times height? Which side of this box will also be length times height? The back. Perfect. The back is going to be the same as the front. That's going to be length times height. So I also have 2 times length times height. One for the front, one for the back. And then you probably see where this is going. We're going to look at the left and right. As we look at the right-hand side of this, we have to be a little bit careful here. That's width and height will give me the right-hand side, width times height. So the right-hand side is width times height. And then similarly, the left is also going to be width times height. So I'm going to have 2 times width times height. And so when I want the surface area of this, the area of all 6 sides added up, I'm going to have 2 length times width. That's my that's my top and bottom. 2 times length times height. That's my front and back. And then 2 times width times height. That's my left and right. And I'm just going to add all those together. And that's going to be the surface area of a box. Volume and surface area are driven by formulas. We saw the formula for the volume of a box was length times width times height. Now when we get to surface area, it's 2 times length times width plus 2 times length times height plus 2 times width times height. So to find the volume or to find the surface area, we just have to be careful when we use those formulas, and we'll plug in carefully, and that's how we'll find the surface area and volume. Are there any questions about the formulas for volume and surface area before I have you try to find volume and surface area of a box? Fantastic. Okay. Surface area and volume of a box. What I want you to do is find the surface area and the volume of a box with a length of 6, a width of 5 inches, and a height of 3 inches. I'm going to set up a poll for this, and then we'll have you solve it. So we're after both things, surface area and volume. One thing important to note here is, the two numbers, the surface area is first and the volume is second. So surface area first, volume second. If you have trouble with surface area on this one, I'll do another example of it. I realize I didn't do one with numbers. And so if you struggle with surface area in this poll question, we'll go back and do one where we'll answer this one, obviously, but we'll also do another surface area example. And to use that formula for surface area, just like finding the volume, we're going to plug in length, width, and height. For finding surface area, we're just going to plug in length, width, and height in the places they go, and then simplify it to have our answer. And I'll encourage you guys to practice outside of class, of course, with the problems that are in the book, the fact that you can do the online homework as many times as you want to before you take a quiz. I'll definitely encourage that. But I also want to encourage you to do the polls in class. If you're doing the polls in class and you're getting them wrong, it's a good idea to ask questions. If you're doing the polls in class and you're getting them right, then you can feel pretty good about the types of questions you're going to see in the book, in the online homework, and on the quizzes. We'll go another 15 seconds and then talk about this one. All right, very strong agreement on this one. That's excellent. And 10 out of 11 had the same number for surface area. That's really good. Okay, so let's go back and take a look at this one. We have this box, and you don't have to draw a picture of it, but I don't know, it always kind of gives me a certain sense of comfort if I have a picture to work with, whether it's a trig question or a surface area and volume question, even a perimeter question, really. So we have a length of 6, we have a width of 5, and we have a height of 3. And so there's the box we're working on. And we're asked to find two things, surface area and volume. Volume goes faster, so we'll do that first. That's just length times width times height. So that's going to be 6 times 5 times 3. And I'll go on my calculator and I'll do 6 times 5 times 3 and end up with 90 for volume. Because this is inches, our volume would be cubic inches. I want you to know it's cubic inches, but you'd be asked for just the 90. The next thing we need to find is surface area. And our formula for surface area is 2 times length times width, plus 2 times length times height, plus 2 times width times height. So there's our formula. We're just going to plug in all the numbers, and then we're going to be careful with order of operations. So we'll have 2 times length times width. If you see anything that doesn't make sense or you're not sure where it came from, let me know. 2 times length times height plus 2 times width times height. Now we've got everything plugged in. We just have to do order of operations. And I know I do anything inside parentheses first. Well, I have parentheses here, but there's nothing to do inside those parentheses. They're just helping me keep my numbers all organized. These are all multiplied, and I have addition. Well, please excuse my dear Aunt Sally. Always the same formula, Antoinette. Yep, you got it. Always the same. For a box. Surface area of a box, always the same formula. And so we'll have 2 times 6 times 5. So let's see. 2 times 6 times 5 is 60. 2 times 6 times 3 is 36. And 2 times 5 times 3 is 30. And we'll add those together. 60 plus 36 plus 30, and end up with a surface area of 126. Since it's surface area, we're going to have square inches because area uses square units. And we have 126 square inches would be our surface area. Idalisa asked if we could do another surface area one, so we'll do that. But before I do another surface area question, I want to see if there are any questions about what we did here. The poll went really well, which is terrific. Basically, what we're doing here is we're using the formula for the volume of a box. We're using the formula for a surface area of a box. All right, we'll do another surface area question. Find the surface area of a box with length 9, width 4, and a height of 2. So this is the rectangle we did volume for, where we have a length, a width, and a height. The length is 9, the width is 4, and the height is 2. And here we're after the surface area. Surface area is 2 times, length times width, plus 2 times length times height, plus 2 times width times height. That'll be the formula for the surface area of a box. You may remember at the very beginning I mentioned boxes and cylinders are what we're going to talk about today. So we're going to see a different formula when we do the surface area of a cylinder but this is the formula for the surface area of a box. So we'll just plug in, and let's see, we'll have 2 times length times width plus 2 times length times height plus 2 times width times height. And that's going to give us every face of this box. And let's see, 2 times 9 times 4 is 72. 2 times 9 times 2 is 36. And then 2 times 4 times 2 is 16. If you see any numbers that you're not sure where they came from or they don't make sense, please don't hesitate to ask. We have to do our multiplication before we add. Now we'll add. And we'll have 72 plus 36 plus 16. This box would have a surface area of 124 square inches. Hey, no problem. The quiz or homework would only ask you for one or the other. It wouldn't ask you for both. I do that in the polls so that I kind of get a 2 for 1. But on a quiz or exam, Antoinette, it's either going to say find the surface area or it's going to say find the volume. It won't ask for both. Good question. All right, let's talk about cylinders. What a cylinder is, what you can imagine for a cylinder, is a soup can. So we have this circular base and we have this vertical part and then we have a circular top. We've drawn a cylinder. And when we talk about a cylinder, there's a couple of things that are important for us to note here. What we have is a circle at the bottom. That circle is going to have a radius. That'll give us how big the circle is. And then our cylinder is also going to have a height. So we have a radius and a height. Those are going to be the important components of a cylinder. And so if I wanted the volume of a cylinder, I'm going to approach it the same way I approach the volume of a rectangle. The first thing I'm going to do is I'm going to find the area of the bottom. I'm going to find the area of what's on the bottom. How much space does that circle take up? Kind of like, I imagine this like a piece of bologna laying on the table. That's area. But if I take that piece of bologna and I stack a whole bunch of pieces of bologna on top of each other, that'll give me the volume. That'll be how much I could fit inside this cylinder. And so what we're going to do here is we're going to find the area of the base and we're going to multiply it by the height. Now the area of the base here, well, it's a circle. The area of a circle, let's see, area of a circle is pi r squared. And so if I want the volume of a cylinder, I need to take the area of that base, that pi r squared, and then I need to multiply it by however tall it is. So we're going to do pi r squared times h. That's going to be our formula for the volume of a cylinder. Volume of a box was different. Volume of a cylinder is pi r squared h. And so if we want the volume of a cylinder, the way that we'll find it is we'll need to plug in for the radius and we'll need to plug in for the height to find the volume of a cylinder. How much can we fit inside this soup can? So let's do that. The volume of my cylinder here is going to be pi. We're going to use 3.14 times the radius, which is 6 centimeters, squared, times the height, which is 15 centimeters. Again, I have to be careful with order of operations. Remember, please excuse my dear Aunt Sally. I do see some parentheses here, but I don't have any work to do inside them. So next I'll move on to exponents. If I have any exponents, I need to do those next. I do. I have an exponent right there. So I need to do that exponent. And I'll do, let's see, that'll stay 3.14. 6 squared will be 36 times 15. And now the only thing left for me to do is multiply all these together. 3.14 times 36 times 15. Volumes for a cylinder can sometimes be a pretty big number. This is 15 centimeters tall, so it's going to wind up being a pretty big number. And here we wind up with 1,695.6. This is volume, so this would be cubic centimeters. And that's the part you'd respond with on a quiz or an exam or homework, even, the 1695.6. This didn't tell us where to round, so we'll just keep the 0.6. But that's the formula for the volume of a cylinder, is pi r squared times h. It's the area of that base multiplied by how tall it is. Are there any questions about what we did there to find the volume of a cylinder before I have you try one? Okay, here it goes. Find the volume of a cylinder with a radius of 2 feet and a height of 7 feet. Round your answer to the nearest tenth. I'll start a poll for this, and we'll see how it goes. We did really well with the surface area and volume of the box. I'm hoping for the same thing here with our volume of a cylinder. I'm optimistic. 1.6 is typically a section that goes extremely well. It's kind of nice. We start out with the quadrilaterals and triangles, things that are pretty familiar. Then we move into the trigonometry and the composite figures, which is a little bit challenging, but then we soften up again at the end with surface area and volume. I like the structure of chapter 1 that way, because we get to do something a little bit softer as we start to prepare for the exam. That's not the case in every chapter, but it is in chapter 1, and I like that structure. We'll go another 30 seconds and then talk about this one. Let's see what I've got. All right, unanimous. Fantastic. That's really good. I expected that we would do well with this one, and we did. That's great news. All right, so the volume of a cylinder is pi r squared h. And here what we have then is we have the volume is going to be pi times the radius, which is 2 feet, squared times the height, which is 7. Really, what you have to be careful of here is making sure you do order of operations properly, so that we have 3.14 times 2 squared times 7, and then we'll multiply these together to end up with 87.92. Doesn't hurt to do a little rounding review a week before the exam. We're supposed to round to the nearest tenth, so we'll find the tenths place. We'll look one space to the right. Since that's 4 or lower, we'll round this down to 87.9. That went great. Now let's talk about the surface area of a cylinder. In the same way that we deconstructed our box and laid it out flat, we're going to deconstruct our soup can and lay it out flat. If you imagine a soup can, what we've got on the bottom is a circle, and the top is a circle that's the same size. And then this part in the middle that goes around the soup can, that's a little bit harder to wrap our heads around. You don't have to really think about cutting the metal and laying it flat. Instead, you can think about the label that's on the soup can. If we were to cut that label off and then open it up and lay it flat, it would make a rectangle. And so when we go to find the surface area of a cylinder, what we're going to do is we're going to find the area of the circle on the bottom. That'll be the same as the area of the circle on top. And then what we have to find is the area of this label that's in the middle. And that's how we're going to find the surface area. We're going to add up the area of those three pieces together. So if we want the surface area of this cylinder, let's see. So let's see, area of a circle. We've looked at that already. The area of a circle is pi r squared. And so as far as the area of the top and bottom go, I'm going to have pi r squared on the bottom plus pi r squared on the top. That takes care of this part and this part. Although, instead of pi r squared plus pi r squared, instead what we could do is just say, well, we have two of those. We have two pi r squareds, one on the top and one on the bottom. If you see something that you're not sure where it came from or it doesn't make sense, just ask. So pi r squared on the bottom, pi r squared on the top, so we have two of those. Now we need the area of this rectangle here in the middle, right here. Okay, so the area of a rectangle, that's how long is it times how tall is it? Well, how tall it is h. That's the height of the cylinder. That part isn't too complicated. But the length of it, like how far what's the distance from here to here? And that could be a little hard to envision, but essentially what we're talking about is this soup can label goes all the way around the circle. That's how long it would be. That's the circumference of the circle. So as far as this rectangle is concerned, what we have here is we have the circumference is one direction and the height is another direction. So the area of that rectangle is going to be circumference times height. Sounds a little weird, but that's what we're dealing with here. Now, if we're talking about the circumference of a circle, see, circumference of a circle was 2 times pi times the radius. I could use pi times d, but I know I'm already working with radius here. So let's go ahead and use the formula for circumference that has radius in it. So the circumference is 2 pi r. So this length here is going to be 2 pi r. And so the area of my rectangle then is going to be 2 pi r multiplied by h. Essentially, it's the length of the rectangle, which is 2 pi r, times the width of the rectangle, which is height. So the area of that rectangle is 2 pi r times h. And so the formula for the surface area of a cylinder is what I get when I add the circles that are on top and bottom to the area of the rectangle. We'll add those together, and that is going to be the surface area for a cylinder. Kind of a strange looking formula, 2 pi r squared plus 2 pi r h. There's a whole lot going on in that formula, but really, if we know the radius and we know the height, we just need to plug those in. We plug in the radius, we plug in the height, and that's how we'll find the surface area of our cylinder. I'll do one of those, and then I'll have you try one. Find the surface area of a cylinder with a radius of 3 inches and a height of 5 inches. Keeping in mind the formula for the surface area of a cylinder is 2 pi r squared plus 2 pi r h. So that's the formula we're going to use, and we just need to plug in and then evaluate it. So what we'll have here is 2 times pi times the radius squared plus 2 times pi times the radius times the height, Finally, we got to use the height. It had to be in there somewhere, and it showed up at the very end. If you don't understand where those numbers came from, or there's anything in there that doesn't make sense, please ask about it. When we evaluate this, order of operations is still important. We do have an exponent right here, so we'll need to do that first. And we'll have 2 times 3.14 times 9 plus 2 times 3.14 times 3 times 5. Now we have multiplying and adding. We need to do all our multiplying before we do the addition. So let's see, we'll have 2 times 3.14 times 9. That's 56.52. And on the other side there, let's see, we have 2 times 3.14 times 3 times 5 is 94.2. And the last thing we'll do is add those together and end up with 150.72. This is surface area, so it's going to be square units, and they're inches, so they would be square inches, but 150.72 is what you would respond with. That's our surface area for this cylinder. How much material would it take to make this cylinder? 150.72 square inches. Are there any questions about that before I have you try one? All right, here goes. Find the surface area of a cylinder with a radius of 8 centimeters and a height of 18 centimeters. I'll create a poll for this and let you try it. You can see from those answer choices that everything's been rounded to the nearest hundred. So even though the page doesn't say it for this one, we'll round to the nearest hundredth if necessary. And the concepts we were talking about in class today were surface area and volume in the context of boxes and cylinders. This is our last poll for today. So we can be patient on this one. We don't have to be in a hurry. We'll go another 30 seconds and then talk about this one. Oh, okay. We'll wait a little bit. Sure. Okay, 15 more seconds and then we'll talk about it. No, it's not a problem at all. I'm glad you said something. Chances are, if you need more time, somebody else does too. You're not only asking for you, which is totally fine, but you're also kind of most likely asking for somebody else too. So please don't apologize for that. Just say it. If you need a little more time, it's never a problem. I think the polls are important for you to figure out where you are, and also for me to get a sense of where you are. I think there's lots of value in it. It's a chance for us to interact. I don't get a chance to look around the room and see people's faces to see if they look like they totally understand or they don't. So the polls are the way that I find that out. So I want to take advantage of those as much as possible. Let's see where we are with this. All right, we're unanimous. Excellent. Usually a good indicator. Not always. We saw a couple times last week where strong answer on a poll didn't necessarily mean everybody had it right, but in most cases, it does. So let's take a look here. We are looking for the surface area of a cylinder. So the formula is going to be 2 pi r squared plus 2 pi r h. And we'll need to plug in. And so we'll have 2 times pi times the radius squared plus 2 times pi times the radius times the height. And now we just need to evaluate. You'll notice again, it's a common theme for us. All last week we would go from words to a picture to an equation. And now we went from words to a formula to an equation. It's a very standard thing for us. Essentially what we're doing is we're modeling. We're taking a real life situation and turning it into an equation that we can use to find the answer to our question, whatever that might be. We've got to follow order of operations. So we're going to do the exponent first. 8 squared will be 64. If you see any numbers that you're not sure where they came from or they don't make sense, make sure you ask. This poll went great, so I feel pretty confident. But 2 times 3.14 times 64 is 401.92. And then 2 times 3.14 times 8 times 18 is 904.32. We'll add those together and have 1,306.24. This is surface area, and they're centimeters, so they would be square centimeters. 1,306.24, that's the number of square centimeters of material it would take to make this cylinder. Are there any questions about that before we look at one more type of problem? Great. This question reads a lot more complicated than it really is, and I'm going to show you a couple different ways to solve it. Whichever one you like better, you can do. If a swimming pool holds 1,900 cubic feet of water and 1 cubic foot is equal to 7.5 gallons, how many gallons of water will the pool hold? So I have this swimming pool and I know how much water it holds in terms of cubic feet. What I want to know is how many gallons is that? And there's 2 different ways you can go about this. Anybody want to venture a guess at how we might go about this? There's 2 ways that I think are both really good. You might like one better than scaffolding, which is dimensional analysis. Excellent, newbies. Let's do that way first. Great, great. So the dimensional analysis thing, because essentially what I'm doing here is I am going to convert cubic feet to gallons. And I have a unit fraction right here. 1 cubic foot is 7.5 gallons. So we can use dimensional analysis on this. Outstanding. So I start with what I have, which is 1,900 cubic feet. And what I know is that 1 cubic foot is the same as 7.5 gallons. Well, let's see. I want cubic feet to cancel, so I need my 1 cubic foot to go on the bottom and my 7.5 gallons to go on the top. Cubic feet will cancel, and then I'll just multiply across the top. 1,900 times 7.5 is 14,250 gallons. Multiply across the bottom, that's just a 1. And so dividing by 1, I have 14,250 gallons. And that's one approach, and it's an excellent approach. If you like that, that's how you could solve a problem like this. Now there's only one left. Anybody want to try to guess or state? You don't have to guess. You can just tell me if you know it, what a different approach for this might be. And it might not be as easy to spot, and that's okay. And if you don't see it, that's totally fine. If you're like, hey, I like dimensional analysis. That looks great. I don't need the other way. That's good too, but I want to show it to you anyway. All right. The other way is to use a proportion. Kind of like we did with similar triangles a little while back. What I'm told is that my swimming pool has 1,900 cubic feet of water, and 1 cubic foot is the same as 7.5 gallons. So 1 cubic foot is the same as 7.5 gallons. And so if I have my cubic feet on top and my gallons on the bottom, I need to do it the same way on the other proportion, or the other ratio. 1 cubic foot is 7.5 gallons. So 1,900 cubic feet is, I don't know how many gallons. So we set up a proportion. 1 cubic foot is 7.5 gallons. 1,900 cubic feet is how many gallons? And then to solve this, we'll cross multiply. 1,900 times 7.5, 14,250. The other way, we get 1 times x. Well, 1 times x is just x. So the number of gallons is 14,250. We get the same answer either way. We better, because we could solve the problem either way. Whichever way you like better. Basically, I think at first glance, this reads like a really hard question. Well, how am I going to turn those cubic feet into gallons? Well, there's a way that we've learned that you can do that. You can use dimensional analysis to turn the cubic feet into gallons, or you can use a proportion to figure out how many gallons would be in 1,900 cubic feet. Either way is just fine. Either way, it's not as difficult as a question as it appears when you first read it.